Hello everyone, and welcome back to a new episode of Advent Code 2016. It's been a while since we did one actually, well, again, not live, but the last few episodes I solved off camera and then we did an analysis on camera. And I thought it would be nice to get back to doing doing one where you actually watch me code it all up. I have read the description for this one, but I haven't started writing any code. So let's dive in. Dragon checksum. Oh, let me zoom in. It's easier zoomed in. Okay. You're done scanning this part of the network, but you've left traces of your presence. You need to overwrite some disks with random-looking data to cover your tracks, and update the local security system with a new checksum for those disks. For the data not to be suspicious, it needs to have some certain properties. Purely random data will be detected as tampering. To generate appropriate random data, you'll need to use a modified dragon curve. Now, I don't know what a dragon curve is, but I guess we could look it up if we wanted. Start with an appropriate initial state, your puzzle input. Then, so long as you don't have enough data yet to fill the disk, repeat the following steps. And they give a simple way to transform a string here. Start with your existing string A, and then reverse it. And in the reversed copy, flip all the ones and zeros, concatenate the original data and the reversed flipped copy, and put a 0 in the middle. Okay, and keep going until you have enough data to fill the desired disk. And you'll probably, I think, it'll overrun, right? You'll need to fill up more of the disk. You'll generate, since you're more than doubling the size of the input every time. I think we're not going to land on exactly 272. So we're going to cut it off at the first 272 generated bytes. And then we'll have our data. And we want to create a checksum of that data. Only for the data that fits on the disk, even if you generated more data. The checksum is created by considering non-overlapping pairs of input in the input data. If the two characters are the same, the next checksum character is a 1. If they're different, it's a 0. And if the length of the checksum is even, repeat until you end up with a checksum, the checksum itself, getting a new thing that's half as big until you end up with a checksum that has an odd length. So I'm a little bit surprised, actually, that it doesn't exactly say what to do about... Oh, I was going to say, what do we do if our initial data is an odd length and we can't checksum it at all? But they've given us an even length here, so that won't happen. All right, so this puzzle, it seems, is sort of doing the same thing, two very, very similar operations, right? We have some data and a way to transform that data into new data, and we want to iterate that process, feeding the output of step 1 as the input of step 2, and so on, until we reach some termination condition. So I feel like that's the function that we want to implement. Iterate until, or something like that, right? So let's grab our input here. And puzzle input equals this. Goal length, I guess. Well, let's not def that, because I get the impression that from this last sentence, the first disk you have to fill has length 272. I get the impression that part 2 is going to be like, hey, here's another disk to fill up. So let's leave that as like a parameter to some function or something. And so I want to see... Actually, I should get the hang of using help of iter tools. Can I do that? Oh my goodness, that's long. So they don't have an iterate function as far as I can tell. But we can write it. Is iterate a special word? No, it's not, so we can name a function iterate. So let's say def iterate takes a function and an x. It yields, well, let's see. So the way I would write this as lazy sequence, let's just for a moment imagine we're writing Haskell. We would, and iterate already exists in Haskell, but if you had to write it again, it would be iterate fx equals x cons to iterate f of x. And that's it, right? We get an infinite list of x, then f of x, then f of x, and so on. Likewise, if we were writing it in Clojure, we would write defn iterate fx to be lazy seek of cons x to iterate fx. So these are some things, you know, in when you have a sequence-based approach, I know how to write this function. With iterator-based approaches, I'm not totally sure. You could like write yield x, and then like for let's say ret in iterate f of x yield ret. So like that's a thing you could do. And I think that some more recent versions of Python, probably including this one, have like yield from, which sort of does the same thing. But this is like going to create some stack depth issues, right? If you have to iterate enough times. We're making the stack deeper and deeper every time. Now, what we could do is we could do something similar, like say yield x, and then say instead of calling iterate ourselves, we could write. No, I guess it would be the same, right? So I guess instead of doing it with recursion, which seems like very much the natural way, we'll have to do it with iteration because that's like Python likes that more. So we'll just say while true, yield x equals f of x, and that's actually like pretty good, honestly. Like I was complaining, but that's a pretty cool iteration / mutation based approach. Okay, so that's our iterate function. And itertools already has take while, so we'll import itertools, and we'll just write def iterate until f and predicate to be just return take while pred. What are you? Help of itertools.take while. Does it have a? No, it doesn't. Okay. Takes the predicate first. Okay. Take while pred itertools.take while pred of iterate. Oh, I guess we need an x. I guess that should be the second. What am I? This is kind of dumb, isn't it? I should just call itertools. I should just call it take while and iterate. Writing another function that combines them both is confusing and doesn't make sense. Okay, so we need functions now that implement the expansion and the checksumming. So let's def expand of a string to be return let's see, s plus 0 plus nothing dot join of I need like an iterator thing. Writing these for comprehensions always feels backwards to me. I can't quite do it naturally. So we want to iterate over reverse of x. So reverse of s. So let's do that. For c in reverse of s. Is that a thing? Can I do that? Reverse of, not returse. Goodness. ABC. No. How do you reverse a string? abc.reverse? Python reverse string? Reversing a string in Python. There is no built-in reverse. There is an extended slice sequence. Fascinating. Okay. So you can... I've only used slices in the normal, or in the simple from A to B. But it turns out you can... Well, here. You can do this. You have a slice with 3 arguments: start, end, and step. And if you leave both the beginning and end empty, and you make the step be -1, it's all the items in the list from the end to the beginning by -1. So great, okay, cool. So instead of reverse, we will write in s of -1. A little bit cryptic, but I imagine that if you've used Python more than I have, it will be just sort of a thing you're used to seeing. So what we now have a C, and we have to basically say 1 if C equals 0, else 0. Right? Oh, yeah, I guess we shouldn't leave our Haskell enclosure code in here, huh? Python doesn't like that too much. So let's write expand of, grab one of the sample inputs here and make sure we get that right. Expand of, I don't know, this one. 5 ones, 4s, no, 4 ones, 4 zeros, 1 and 1. That didn't work at all. Did it? Oh yeah, it did. 4 ones, 4 zeros, 101, couple zeros. Yeah, it looks good. The result that we were supposed to have gotten, actually, I'm going to just test it. Yes, great. All right, so that's expand. Nice and easy. Def checksum of a string is, let's see, how do we checksum? We break it up into pairs, and we test the parity, whether they're the same. Okay, so this is an opportunity to something that I complained about previously, not being able to find in Python a partition function that splits an input list or iterable into chunks. And you can build it yourself out of like iSlice, but that's rather cumbersome. And I talked to someone who does a fair amount of Python, and she was just like, that's not too bad to do it with iSlice. Okay, fine. But I was reading through the itertools docs. Was it this morning? Who knows? Sometime recently. And zip is a thing you can do, which of course I knew. And I know that like in, say, well, no, I was going to say in like Clojure or Haskell, you might zip a thing in order to partition it, but it's sort of not what I meant. What is true is you might zip with a thing after partitioning it in order to transpose it, for example, or something. But that's not what we're talking about. And I noticed the itertools documentation just like mentioned in the documentation for one of the functions, like, by the way, you can use this to implement something that's like partition. and it was a little bit spooky. So let's I'm sure we could write this as one line, but I'm not sure it's a great idea. So let's first just write. I wanted to show you how partition would work. So let's write a function called pairs, def pairs of s, I suppose, to be return zip of star of iter s times 2. And pairs in a range of 8. Indeed. So what the heck is this? Why does this work? Right? We take the input sequence and we construct one iterator on it, and then we make that a list and multiply it by 2, so we have a list with 2 copies of the same iterator of the input list. And then we pass those as the 2 arguments to zip. What? Why? So zip guarantees that it will iterate over... if you pass it in like 3 iterators, it guarantees it'll look at the first item of the first, then the first item of the second, then the first item of the third. And then the second item of the first, the second item of the second, the second item of the third. That's a guarantee that zip makes. And it points out that, hey, you can make use of that guarantee by passing multiple iterators over the same input sequence, or rather, passing the same iterator multiple times, taking advantage of the side effect of calling next on the first time to mean that, like, hey, when you call next the second time, it'll show up as if it were the second list. Wow. Weird, huh? But that's pretty cool that this works. And I will have to tell this person who uses Python that, like, hey, actually partition is a lot easier than this nonsense using islice and iterating yourself. Okay, so how about checksum? So what we will return basically is return a generator. No, return a list. It could be a generator, but it might as well be a list, right? Nothing.join of, now a generator expression, 1 if x equals y, else 0. Wait, is it supposed to be a 1 if they're the same or a 1 if they're different? If they are the same, it's a 1. Okay, fine. So for xy in pairs of s. And so you can see now that actually we could have fit this all on one line, taking pairs and put it here. It certainly fits. But I think it's not like that important to do that. But also having pairs there makes it a little clearer what's going on for people who, like me, are a little bit less used to Python's everything. So let's test our checksum function by taking example. Is that equal to what it should be, which is this? Yes, great. So that's our checksum function. So now we have expand, and we have iterate, and we have take while, and we have checksum. So those are all the basic building blocks we need for our main stuff, what we're going to do. Is there a way? Python last iterator. What is the last? How can I find the last thing in an iterator? Huh. Okay. All right, so good point. You could reduce over it. There's also suggestions. Oh, here, I should show you guys. Why not? Suggestions that you could do a for loop over the iterator, and apparently the variables that you put in scope for a list operation leak out, I guess. So this is a similar solution, but oh, I see. It relies on variable leaking. Actually, that's okay. The difference is just that this one allows you to set a default value, and so it's seen as a bit cleaner, which is fair, but we don't really need it. So let's just def last of x's to be for I in x's pass return I. So this is consuming the whole sequence, but that's fine. Actually, you know what we should do? We should combine this with take while, so that we have. Because all we're gonna do is we're gonna take while a thing is true and then call last twice. So let's just have a function that does that. Def let's see. Actually, for the expanding pass, we don't really want take while, do we? We want drop while. We want to drop while the input is too small and then take the first. And for the other one, we want to take while the input has 2 characters and look at the last one. So maybe it's not really worthwhile to define a new thing for either of those. So we'll just define a function called checksum after filling checksum of expanded data, checksum. We can call it solve, but filled disk size. There we go. All right, bad name, but it's not the worst name. So let's see. We'll have what are we gonna do? Let's see. We have no puzzle input, so we can get rid of all this garbage. Print checksum filled disk of 272. Yeah, 272. Fine. Excuse me. Got something in my throat or something. I don't know. Checksum a filled disk. So what we're gonna do is expansions. Nice. Okay. Equals iterate expand of puzzle input. Now what we want is the first of the drop while. Is that right? Yes. So data equals expansion drop while lambda of s return s len of s less than size and expansions, and we'll just call .next on that and get the first size elements out of it. And let's just for now return data so we can see if it's like working at all. Oh, you don't have to put a return in the lambda. That's right. Okay, so what's a checksum filled disk of 272? No good. Drop while. Itertools.drop while. Itertools.drop while. And note, of course, we could inline this, right? we could put it here. I certainly would do that in Clojure or Haskell, but there's no particular need to, and I don't think it's a Python style thing to do that. Okay, well here's the data that we're going to put on the disk. That seems fine. Checksums equals iterate checksum of data, right? Yes. For checksum in checksums, pass, return checksum. So really, all of these things could be inlined together into like just this. For checksum in iterate checksum of itertools.dropWhile lambda s len of s less than size expansions.next. Oh no, I skipped. I needed to expand this one in line. All right, doesn't matter. It was okay, and we need to know the correct checksum is what we need to know. So that's fine. That seems like I guess since we're doing this in the REPL, might as well just do this, right? I already did that. It's right here. Local variable checksum referenced before assignment. Ah, yes. C in checksums, return C. It was annoyed that apparently if you have a local here, actually, well, here, it's valid in scope for the whole function, not just when you define it. So the function name checksum we were trying to use clashed. Okay, that's... Uh-oh. I forgot. Stop. I forgot to drop while it, or take while. Itertools.take while lambda s len s mod 2 equals 0. Oh, but that's not what I want either, is it? I don't want to get the last one that's even. I want to get the first one that's odd. So this is another drop while, and then first. Yeah, drop while it's even. Dot next. Okay, so actually let's def last of x's return. No, I don't want last. But in both of these, I want the first. What I want is I want the first thing that doesn't satisfy a predicate. So first, not pred x's, I guess. So we return itertools.drop while of pred x's dot next, right? First not okay, how about that? 0. What? I don't think that is correct. What has gone wrong? Oh, whoops. We still have this for loop here. We just want to, in fact, return first not of this. Okay, that's more realistic. Let's see if that's the answer. That's the right answer. All right, great. Well, let's git commit before we forget. Day 16, part 1. And check out part 2. We have a much, much larger disk. Okay. I figured it would be larger. But this is large enough. Well, I mean, I don't know. Python source input. Oh, whoops. Let's go print checksum filled disk of this. We'll start this program running, I guess, but I don't think it's going to finish anytime soon. I think they're asking us to figure out a more efficient way than actually computing the sums. Right? Well, actually, So, yeah, okay, it's not so bad. I forgot that we were, I forget, what were you guys even looking at while I was doing that? You were looking at the browser window. Okay, well, fair enough. All I did is I changed this. Nothing very exciting. I was worried that it was much larger because I thought we had like some quadratic factors in there or something. And like we kind of do because we're doing n work for an n-sized string. And we have to do that like... But all the exponential growth on the way up, sort of. So we're kind of just doing 2n work. I think it's... Oh boy, do I really want to go out on a limb and say it's linear in the size of the input? I don't know. I think it might be worse than linear, but it shouldn't be worse than quadratic. And honestly, I think it's still linear. I don't know. Well, this is good news. It means that we... this is going to be the smallest day 2 commit I've ever made, I think. Look at that. Boop. Day 16, part 2. Great. Well, I wonder if there is a more efficient way to do it. I don't know. Cool, I guess. Learned some neat tricks. We used this cool pairs zip thing to get pairs. We learned how to reverse a thing. We wrote, probably some ugly conditional expressions here, but it's not my fault. Python's only way of doing inline conditional is very long. Well, honestly, it's not even that long. It just is a little bit weird, and that's just my prejudiced opinion. Iterate, honestly, pretty cool way to write it. Thought it was going to be kind of annoying and gross because I was going to do it with recursion. But by doing it with mutation and generators, the stuff that's built in, that the language wants you to use, it came out pretty cool. So thanks for that, Python. Anything else to comment on? In Haskell or Clojure, I might have noticed that this combination of first not and a lambda that's based on size is repeated, and I would have written a function that takes in a function as an argument, and that function is expected to take a list's size as input, and so it would be we could do it in Python too. It just isn't going to look as nice, I suspect. So let's say a def first sized, let's say, f and x's. It could have been, let's see, return first not of... Yeah, so it's not as good in Python, I feel like, because we're still going to have to write a lambda. All we're really removing is this len call, right? And the awkward part is not the call to len, it's the fact that there's a lambda at all. So never mind, that's not a valuable improvement. Yeah, all right. Nothing left to do. Hope you guys have enjoyed. Thanks for watching, and I'll see you next time.